Hi everyone. I'm just going to go over the answers to the circuit analogies worksheet that you have. And just so you know, the notes are also posted online. So over here, let me just show you. Okay, so under Brightspace, under Content, just make this bigger, okay? Under Unit 1 Electricity, Chapter 11 Current Electricity, and then if you scroll down, I have March 28 and 29 notes, and you'll notice that it's there, okay? So just listen for now, and then if you haven't copied down the answers from previous, you can definitely just refer back to that, okay? And I'm going to do the same thing for the Ohm's law notes as well. Okay, so let's get back over to here. Okay, so here's circuit analogies. So over here in figure 1, what we have is a water wheel. And what we're doing is we're just using this as an example or an analogy. And so you can draw from this similarities in terms of the characteristics of the properties of things related with electrical current. Okay, so over from here, when we're talking about a water wheel, the water wheel is turning. The water drops down into here, which is a water reservoir. And what happens is that when the water returns and it gets pumped up, at first it's very low pressure, but as it goes through the pump, it gets pressurized so that it can actually go through the tube or the pipe, and then return over to here and continue to turn the water wheel. Okay. Over here, what you'll notice is that there's also a valve. It's kind of like a switch to turn things on and off, and so you can stop the flow right over here, but it's high pressure right before here, and then as it goes around here, it gets to be lower and lower pressure, and then it has to get kind of like pumped up over here. Okay, so let's just look at this. And based on the notes that you copied from 11.1 and 11.2, I'm hoping just to solidify your understanding and so that you really understand what the difference between current, potential difference in voltage, and also resistance is, because we're going to have to know that for Ohm's law. Okay, so from the analogy that we're drawing from, which is the water wheel, we've got water pressure, the water pump, the water wheel, the flow rate, the pipes, and the valve. And then over here in the circuit, there's different circuit components or circuit characteristics, and we just have to match them up properly. So there's wires, current, load or resistance, potential difference, which is the same thing as voltage, a switch or a battery. Okay, and so over here, when we think about the water pressure is how much force is pushing the water. Okay, and so that's actually like D, okay, which is potential difference or voltage. Okay, so I want you just to copy down also the fact that it is the force pushing forward. Okay, so the electrons are getting pushed forward by a force that is called potential difference or voltage. The water pump is what actually takes these low voltage water, pumps it up and sets it to high pressure. Okay, and so over there, that's actually the function of the battery. Okay, so the battery pumps up the electrons and gives them more force or pushes them. Okay, the water wheel over here is talking about C, which is the load or resistance. So it's kind of like the force pushing against. This is where the analogy breaks down a little bit, to be honest. But the idea here is that there's some sort of a load. So if there's a water wheel right here, maybe this water wheel is connected to like a mill. That means that, for example, there's two plates or two big rocks that are grinding together, and they are making flour out of grain, for example. Okay, that uses some of the force that's changing the water force into like kinetic energy, and it is getting used up because it's grinding flour, for example. Okay, so this is like the load, or let's just say that there was a motor here. That's kind of like likening that. So that's called the load or resistance. Okay, the flow rate. So when we think about how much water is flowing and at what speed it's flowing, that is the flow rate. And the flow rate can be likened to the current. Okay, So it's the number of electrons flowing past a certain point. So if I were to, like, for example, sit right over here and observe, the flow rate or the electric current would be how many electrons are passing this point every second, for example. Okay? Next up, the pipes are like the wires. They are the conductive material that let the electrons flow through. Okay? And then finally, the valve is like an on-off switch. So it's like E, which is like a switch. Okay, so I hope that this analogy helps you a little bit to understand what these different terms are, and we can draw from our understanding of this water wheel example. Okay, now what we're going to do is move on and just think about these different figures, what's similar and what's different. Okay, and then again, we're going to liken this to some characteristics related with current electricity. Okay, so if we compare A and B, what we notice is that certain things are different and certain things are the same. Okay, so one of the things that is different is that hole B is larger. Okay, so if there was a cup and it was filled with water, but there was a little hole at the bottom of this one, but then a bigger hole over here, hole B is larger, which means that more water flows through. Okay, what we notice over here is that the water level is the same in both cups. Okay, so what does this represent in a circuit? It represents, for example, in B, there's less resistance because hole B is larger. Okay, this means also that when there's less resistance, the current or the flow increases. So there's going to be more water flowing through here. There won't be as much resistance pushing back, like the walls of this cup are pushing back on the water and not allowing it to flow as quickly. So over here, the current or flow increases. And then the thing that stays the same is actually that the potential is the same. That means that the amount of like force that's pushing down on both of these is actually the same because the water level is the same. Okay, so take a few moments, wrap your mind around that. Okay, for cup C and cup D, what changed was that water level D is higher. Okay, what stayed the same? Sorry, the other thing that's different is that the length, like how far the water is kind of flowing out, that's also different as well. Okay, and then what stays the same? Oh, sorry, and then if the length of the water stream is longer in D, okay, and then what stays the same is the width of this hole right over here. So the width of this hole is supposed to be the same in both of them, okay? So what does this represent in a circuit? It represents that there's more voltage or potential energy. So if you can imagine the pressure that's pushing down on this water flow right over here, the pressure will be very low right over here, whereas over here, because it's higher, there's more voltage or potential energy, and so then the stream actually flows longer. Okay, so this means also that because there's more voltage, also what will happen is that there's going to be more current as well. Okay, one last analogy to just understand the idea of voltage, current, and resistance, okay, is we've got this really weird diagram, so sorry in advance, but we've got this really strange diagram. We have someone, there's like a flexible tube right over here. Someone is crawling through, but there's a person that is restricting right over here and narrowing the hole. And then there's someone here that's like kicking this other person forward, okay? So we've got A, B, and C, and they each represent either voltage, current, or resistance, V, I, or R, okay? And so which figure represents resistance? Well, it would be A because they are restricting the movement, okay? Which figure represents voltage? Well, voltage is the pressure or the force that's pushing, so that would be B because it's the force pushing, okay? And then for C, which one represents current? Well, it's obviously C, which is the movement or flow of electrons. So just imagine these are electrons passing through this point, okay? I hope that helps. And then we're going to need this information to understand Ohm's law. Okay? Okay, see you on the next video.